Hi Diksha Didi, good evening.
Hi, good evening.
Alright, so in the last class, we were on clearing the input buffer, and now we are going to move on to operators, right? So
Okay.
let's just get started. All right, so we are gonna do operators in C++. So an operator is a symbol that operates on a value to perform specific mathematical or logical computations, like your plus, minus, every all of these are operators. So they form the foundation of any programming language. So what?
Nothing, sorry.
All right. They form the foundation of any programming language, right? So without operators you would not be able to do much in programming, right? So operators are very important. So in C++ we have built-in operators to provide the required functionality. So we have built-in operators. So built-in operators means that C++ provides these operators for us to use, right? So an operator operates the operands, right? So it operates the operands, like the plus operator. What it does, it adds the first operand and the next operand, right? So if you have a plus b, it will add a and b, right? Similarly, the subtract operator, it will operate do operations on the operands. Operands will be a and b, right, which it will subtract, right? So here's an example of int c equals to a plus b. So whatever a value is and whatever b value is, those will get added and will be saved in the c variable. So here the plus is the addition operator, a and b are the operands that are being added, right? So plus is the addition operator, and a and b are the operands that are being added. So operators in C++ can be classified into 6 types. So there are 6 types of operators. We have arithmetic operators, we have relational operators, we have logical operators, we have bitwise operators, we have assignment operators, and we have ternary or conditional operators. That we are gonna see all of these operators in detail, right, in this course, right? So over here, here's the type of table, right, for all of our types of operators. So you have operators and their types. So your plus, plus, minus, minus. So when we give two plus symbols and two minus symbols together, like a plus plus and plus plus a, or a minus 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 a, those are called unary operators. Then we have plus, minus, multiplication, division. All of these are arithmetic operators. Less than, equals to, greater than, equals to, double equals to, not equals to. That is, those are relational operators. Double and, double or, double not, these are all logical operators. You're all gonna see this all of these operators in detail, right? So then we have and, or, left shift, right shift, one's complement, XOR. All of these are bitwise operators. And then we have equals, plus equals to, minus equals to, multiplication equals to, etc. On all of these are assignment operators. And then we have the ternary operator, right? So all of these, first of all of these together, arithmetic, relational, logical, bitwise, and assignment, all of these operators together form binary operators, right? So these are also, all of these together are called binary operators, as they are performing some mostly they're like your plus, minus, all of these operators mostly are performing operations on numbers, right? So that's why these are all called binary operators also, right? Together these are called binary operators. And then we have the ternary or the conditional operator. Over here, this is the ternary operator that we saw previously also, where this is like a kind of shorthand if statement. So if else statement, you can say that if something happens, then the code after the question mark will be executed, else the code after the colon will be executed, right? So here was a simple table on operators. Now we are gonna see all of these operators in a bit brief, right? And all of these operators have their own chapter also, where we are gonna understand these operators in detail. So first we have arithmetic operators. So these operators are used to perform arithmetic or mathematical operations on the operands. So these are used to perform mathematical operations on the operands. For example, the plus is used for addition, minus is used for subtraction, multiplication is used for multiplication, and etc. So there are two types of arithmetic operators, right? So one type of operator is arithmetic operators, like which are used to perform operations on mathematical operations, right, on the operands, right, on integers, right, and or you can say on numbers, right? So these are used to perform mathematical operations on numbers, right? And further of arithmetic operators, we have two types. We have the unary operator, that is a type of arithmetic operators, and then we have binary operators, that are also a type of arithmetic operators, right? So first we have unary operators. So these operators operate or work with a single operand. So mostly your operators have two operands, right, or more. But unary operators, as the name suggests, there is only one operand with which the unary operator works with. So for example, the plus plus and the minus minus operator, right? So increment operator is the plus plus operator that increases the integer value of the variable by 1, right? So if we have a and we just say a plus plus, so now a's value will be set to 6, right? We also have the decrement operator, minus minus, that if you say like a is equal to 5 and you say a minus minus, so it will subtract the value of a by 1, right? So 5 will change into 4, right? So in the increment we were getting a6, and in decrement we were getting a as a value of 4, right? So a's value was set to 4. Similarly, another way to use the unary operator is instead of giving the plus plus after the operand, you can give the plus plus before the operand. So you could have said plus plus a, and same with minus minus. Instead of giving it after the operand, you can have given it you could have given it before the operand. So you could have also said plus plus a and minus minus a, and right, and that would have also worked perfectly. But there's a slight difference between a plus plus and plus plus a that we are going to see in the example that is over here. Alright, so over here we have an a variable 10. We are then showing we are saying see out a plus plus is a plus plus value, right? So we are just trying to show the value of a plus plus. So logically it should increment the value of a and then it should return that value. So logically it should return 11 over here, but no, it returns 10 because this is called postfix increment. In postfix increment, what it does is first returns the value of a, right? So over here a's value initially is 10, so that is getting returned, right? And then it is getting incremented, right? So we are first getting the value 10, right? So it will show 10, right? And then a's value will be set to 11. So on the screen we'll get a plus plus is 10, but a's value after printing this, a's value will change to 11. So now after this statement a's value is 11. Now when we try to print plus plus a, right, and so this is called prefix increment. So a's value is already 11, right? So we have a's value already 11. So what prefix increment will do, it will first increment the value of a and then return it. In postfix increment, first it was returning the value of a and then incrementing it, but in plus plus a it is first incrementing the value and then returning it. So we know that already the value of a is 11, right? That is getting incremented and it is getting set to 12, right? And that is getting returned. So what we are getting 12. So as we had 11, 11 got incremented, so it was 12 and 12 got returned. So over here we got 10, over here we got 12. Now we have the same thing with the postfix and prefix decrement operators. So we have b equals to 15. When we say b minus minus, it will first return the value of b. So it will first return 15. That will be shown on the screen, right? And then it will decrement the value of b. So it will show on the screen 15, right? And after this statement b's value will be 14. and then when we say minus minus b, it will decrement the value of b first, so it will set 14 to 13 and then it will show the value. So over here we got 10, then 12, then 15 and then 13. So we are getting a plus plus is 10, then plus plus a is 12, b minus minus is 15 and minus minus b is 13. So this is called prefix decrement, this is called postfix decrement, this is called prefix increment, and this is called postfix increment. Alright, so note plus plus a and a plus plus both are increment operators. So these both are increment operators, however both are slightly different, right? So both are slightly different. In plus plus a, the value of the variable is incremented first and then it is used in the program. So as it was happening over, it first incremented the value and then it was getting used, we were using it. In a plus plus, the value of the variable is assigned first and then it is incremented. So over here in a plus plus, the value of a is getting returned, right? So a plus plus is the original value we are getting and then it will get incremented. Similarly happens for the decrement operator, right? So it's similarly it happens for the decrement operator also, right? So now in arithmetic operators we have seen unary operators. Now the second type of arithmetic operators is binary operators. So I just want to make sure that the unary operators concept is clear.
That's clear.
All right. So binary operators, these operators operate or work with two operands. So binary operators are used to work with two operands. Your binary, there are two types of binary operators that let's just make it clear, right? To work with binary numbers, right, we call them bitwise operators. Over here these are bitwise operators where we work with binary numbers. Binary operators are working with normal numbers, right, but they have two operands. So for example addition operator, that is a plus b, 2 plus 5, right? So there are two operands, like 2 and 5 are two operands. Similarly with subtraction, a minus b, so and a and b are two operands, right? So binary operators, the difference with between unary operators and binary operators are that binary operators work on two operands and unary operators work on one operand. So first we have the addition, the most common binary operator that adds two operands. So we have a equals to 3, b equals to 6, right? And then we have c equals to a plus b. So 3 plus 6 is 9 and that is set as the value of c. Then we have subtraction, that subtracts the second operand from the first, right? So we have a equals to 9, b equals to 6. So when we say a minus b, it will subtract 6 from 9 and it will set the value of c to 3 over here. Then we have multiplication, that multiplies two operands. We have int a equals to 3, b equals to 6, and then we multiply both the values. So we have 18 as the value of c. Then we have division, that divides the first operand by the second operand. So we have 12, we have b6, and when we say a divided by b, so 12 divided by 6 is 2, and that is set as the value of c. Then we have the modulo operator that returns the remainder, an integer division, right? So it returns the remainder of a division. So like we have over here 8, over here we have 6, right? So when we say 8 divided by 6, we get the remainder to be 2, right? So that remainder we are getting from the modulo operation or operator. So here's an example. We have a equals to 8, b equals to 3, and then we are using all the operators. When we say a plus b, we'll get 11. When we say a minus b, we'll get 5. When we say a into b, we'll get 24. When we say a divided by b, we'll get 2. And when we say a modulo b, we'll get 2. So over here, when we say a divided by b, it does 8 divide. Let's just run this once. Alright, so over here we are getting 2, right? Though it should have given us a decimal value, like 8 divided by 3 is 2.6 something, right? But it is giving us 2 as this will only return us the integer value, right? This won't return us the decimal value. When doing a divided by b, it won't give us the decimal value, it will only give us the integer value, right? And it will take the rest as remainder. So when doing a divided by 3, it will just return 2, right, and the remainder will be 2, right? So 8 divided by 3 will get a value 2, right, and not a decimal value, and when we check its remainder we'll get the remainder 2, right? So these are arithmetic operators. Next we have relational operators. Alright, so these operators are used for the comparison of the values of two operands. So these are basically used to compare two values. For example, the greater than sign checks if one operand is greater than the other operand or not, etc. So the result returns a boolean value, true or false. So first of all, it is going to check if it is going to compare two operands basically, and in the end this will either return true or it will either return false, right? So over here we have equals to a relational operator that checks if two values are equal. So like over here we have a equals to 3, we have b equals to 6. When we say a equals to b, right, then it will check 3 equals to 6, right? So now we know that's a false statement, so it will return false. Then we have the greater than operator, right, that checks if the first operand is greater than the second operand. So we have a equals to 3, b equals to 6, right? And when we say a greater than b, so when we check 3 greater than 6, right, we know that 3 is not greater than 6, so the program will return false, right? Then greater than equals to, that will check if the first operand is greater than or it is equal to the second operand. So over here if we give a equals to 3, b equals to 6, and we check a greater than equals to b, right? So now 3 is neither greater than or neither it is greater neither is greater than or nor it's equals to 6, right? So 3 is not greater than and it's not equals to 6, right? So this will return false. If we had a equals to 6, then what would have happened? It would have checked if it is greater than. So we know 6 is not greater than 6, but when it would have checked equals to, then it would have gotten true, right? So if a would have been 6 and b would have been 6, a greater than equals to b would have given us true, as it would have checked either it should be greater than or either it should be equals to. So when it would have checked 6 greater than 6, that was false, but 6 equals to 6 was true, so the whole thing returns true. So if a was 6 over here, we would have gotten true. Then we have the less than operator. So if it will check if the first operand is less than the second operand. So it will check if the first operand is less than the second operand. So we have a equals to 3, b equals to 6. So when we say a less than b, we are checking 3 less than 6, right? That is true, so this will return true. Next we have less than or equals to, right? So this will check if the first operand is less than or it is equal to the second operand, right? So it will over here we'll check a equals to we have a equals to 3, b equals to 6, a less than equals to b. We know it's not equals to, but it is less than, right? 3 is not equals to 6, but it's less than 6, right? So one of the conditions is true, so the whole thing returns true, right? So 3 less than equals to 6 also gives us true. And finally we have not equals to, that will check if both operands are not equal, right? So this is the inverse of equals to. Equals to checks if both of them are equal. Not equals to will check if both of them are not equal. So we have a equals to 3, b equals to 6, and when we say a not equals to b, right, that is true because 3 is not equal to 6, so it gives us true, right? So over here we have seen many operators, the comparison equals to, greater than equals to, less than equals to, and not equals to. Now we are gonna see all of these operators in action, where we have a equals to 6, b equals to 4. So let's just try to evaluate all of this ourselves. A equals to b, this will give us false. A greater than b will give us true. Greater than equals to b will also give us true. Less than b, a less than b will give us false, as 6 is not less than 4. A less than equals to b will also give us false, and a not equals to b will give us true. So over here we are getting a equals to b false, that is represented by 0. A greater than b we are getting 1, that is basically the representation of true, right? And then we have getting from greater than equals to 1, right, that is also representation of true. Then less than equals to, both are giving 0, right? So that means they are giving false, right? And not equals to is giving 1, so that is true. So here 0 denotes false and 1 denotes true. So 0 is false, 1 is true. So to read more about this, please refer to the article relational operators. So we are going to see about relational operators further in the course. Next we have logical operators, right? So we have seen relational operators and arithmetic operators. Now we are on logical operators. So these operators are used to combine two or more conditions or constraints, or to complement the evaluation of the original condition in consideration. So basically logical operators are also used for comparisons mostly, right? So we are gonna see the usage of this, right? So the definition over here is, you can say in bookish language, you can say that is used to combine two or more conditions or constraints, or to complement the evaluation of the original condition in consideration, right? So we're gonna see examples and it should be more clear. So the result returns a boolean value, true or false. For example, we have the symbol and, right? So when we say two ands, this is actually logical and. So it will return true only if all the operands are true or non-zero. If all of the operands we give over here on the left hand side, right hand side, if all of them are true, then we are gonna get true. So we are saying a equals to 3, b equals to 6, right? So we are saying a and b. So now both of these are true values, right? Both of the a also has a value, b also has a value, and these are non-zero, right? So this will give us true, as a is also a value, b is also a value. So a and b will return us true. If one of them would have been 0, then it would have been a non-zero value. So if a, for example, would have been 0, then it would have checked 0 and b. So 0 represents false, so it would have checked false and true, and whenever one of the operands is false, then the whole thing would have given us false. So if a or b would have been false, then the whole thing would have given us false. Then a and b would have given us false, right? So over here we are getting true right now. Over in the left hand side and the right hand side, we could have also got any condition, right? So we could have said 2 equals to 5 and 6 is greater than equals to 6, right? So 2 equals to 5 is false, 6 greater than, okay, we are gonna look check the we're gonna test it out in the example only right now, as verbally it may not be that clear. Let's just read all of these operators and then we are gonna fiddle around with them. Next we have logical OR, that those are two pipe symbols that returns true if either of the operands is true or non-zero. So if either of the operands is true or non-zero, then the whole thing will give us true. So we have a equals to 3, b equals to 6. So a or b, right? So 3 is non-zero, so that will give us true. 6 is non-zero, so that will give us true, right? So both of them are giving true. So if both of them or one of them will be giving us true, the whole thing will give us true. So this returns true. And not, that will basically reverse the result. So if we are getting true, then not will give false. And like if you have a true value, not true will give us false, and if you have a false value, not false will give us true. For example, a equals to 3, not a. So a is true, right? So a is a true value, right? So not true will we are using not before the not operator before the true value, so it will change the result to false and it will give us false, right? So we have seen and, or, and not. Now we can just use all of these logical operators. So for example, over here we have seen the example a and b, a greater than, alright. So over here they are not using the or operator, right? So that's not a problem. We're gonna test all of the operators. So over here a and b we have already seen. We could have given two conditions also, like a equals to 6 and b equals to 5. So first it will evaluate the left hand side, then it will evaluate the right hand side, then it is going to check if both of the values on left and right hand side are true, then the whole thing will give us true. So now a equals to 6, that is true, right? B equals to 5 is false. So true and false will give us false, right? So the whole thing will give us false, because true and false, when both the values are true on the left hand side and the right hand side, then the whole thing will give us true. When you say true and false, then if one of the value is false, then what will happen, you have one of the values is false, so it will give us false, right? So both have to be true to get true. If one of them is also false, then we'll get false, right? So over here we are going to get false or 0 in the first one, right? So we are getting 0 over here, right? So now we could also use the or operator. So A or B we have already seen. Let's just give the same condition. A equals to 6 and B equals to 5. So now B equals to 5 is not true, but A equals to 6 is true, right? So this is true, this is false. And as one of the conditions is as one of the operands is true, that's why we'll get true over here, right? As one of the operands is true, we'll get the value 1, right? That will represent true. So we are getting 1. And when we say not b, b is a true value as it's 4 and it's not 0, it's non-zero, right? And when we say not, it will basically reverse the result. So true will change to false and 0 is the representation of false. If we would have said b equals to 0, right, not b equals to 0, then b equals to 0 is your false. B equals to 0 will give you false, right? As b is 4, and we are checking 4 equals to 0, so that will give us false, right? But then when saying not before it, when giving the logical not operator before it, it will just reverse the result. So false will change to true, right? So not b is 1 we'll get, right? So we'll get 1 from this. That will be representing true, right? So we have seen logical or, we have seen logical and we have seen logical not. I hope all of these operators are clear.
Yeah, they're clear.
All right. So now we are on bitwise operators, right? So bitwise operators are very interesting. We have already seen them in our previous basic tutorial, right? But we are going to see them in detail in their own chapter, right? Right now these are just this is just a brief of bitwise operators. So let's just continue. So these operators are used to perform bit level operations on the operands. So these are used to perform bit level operations on the operands. So the operators are first converted to bit level and then the calculation is performed on the operands. So first they are converted to bit level, right? So into zeros and ones, and then the calculation is performed on the operands. So mathematical operations such as addition, subtraction, multiplication, etc. can be performed at the bit level for faster processing, right? So using bitwise operators, you can perform operations at the bit level, right, for faster processing. As when using these operators, you're directly you're directly just working with bitwise operators, and the conversion part your computer doesn't have to do. And when using integers, you are actually first converting the integers into bit level, right? And then what you're doing, you are using the operators for integers, right? That operation will be converted into a bit level operation, and then you'll get the result. Over here with bitwise operations, you just you are getting you're giving it bit level values, right? Or and you're just using a bitwise operator, so that conversion part that was there in between is now skipped. So the operators are first converted to bit level and then the calculation is performed on the operands. So mathematical operations such as addition, subtraction, multiplication, etc. can be performed at the bit level for faster processing. right? So we have binary and, right? So we are just gonna look this in we are just gonna check all of this out in brief, right? And in detail we are gonna see later, right? In the next few chapters. So binary and what it will do, it will first convert the integers, the operands that are integers into bitwise bit level, right? So like we say 2 and 3, right? So it will binary, and what it will do, it will check if both the corresponding bits, right? So for example, let's just leave 3 and 2's example. If we have 1001 and 10110, right? So if binary, and what it will do, if two bits, right, if the corresponding bits, like if the rightmost bit and then the next two bits and then the next two bits, right, if the corresponding bits of both the numbers are 1, right, or are true, then you will get, then and will return 1 for that bit, or else it will return 0, right? So if both the bits of your if you have both the bits you have true, right? So if your both the bits are true, then what will happen, then only it is going to return you 1, right? So if you have 100, or let's just take 1101, and you have let's just write it somewhere. All right, so over here let's just write it. You have 1101 and you have 0110. So over here, what this will check, it will check from the rightmost bit that if both the corresponding bits are 1, then this thing will return you 1. So over here 1 and 0, so this will give you 0, right? So this will give you 0, right? 0 and 1, this will also give you 0 because both the bits have to be 0, both the bits have to be 1, sorry. Now you have 1 and 1, 1 and 1, both the bits are 1, both the corresponding bits are 1, so over here you'll get 1. And 1 and 0, one of the bits is 0, so you'll get 0, right? So 1101 and 0110, when we have two bitwise numbers, and when you use the AND operation, when you try to do the bitwise AND operation on these, then what you'll get 0100, right? So I hope this AND operator is clear.
That's clear.
All right, so next we can move on to the binary OR operator, right? That copies a bit to the evaluated result if it exists in any of the operand, right? So you can, this is just a bit complicated language. What OR basically checks, if one of the bits is 0, right, or if one of the bits is 0 and the other bit is 1, then OR will return 1. So let's just look at it with an example. So let's just have this let's just take the same example of 1101 and 0110. So if one of the bits is 1, it is going to return 1. So 1 and 0, one of the bits is 1, so it is going to give 1. 0 and 1, one of the bits is 1, so it is going to give 1. 1 and 1, so now both the bits are 1, so if one of the bits has to be 1, right? So if both the bits are 1, then it is going to be giving 1. And 1 and 0, one of the bits is 1, so it is giving 1, right? So if any of the bits or both the bits are 1, right, then it will return 1 on that place. Next we have binary XOR, right? So what this does, it copies the bit to the evaluated result if it is present in either of the operands but not both. So now this is also complicated language. Let's just look at it by an example. So over here what happens, when you have 1 and 1 and you have 0 and 0, then it returns 0, right? And when you have 0 and 1 and or 1 and 0, then it will return 1. So let's just look at it by an example over here. So you have over here you have 1 and 0, so this will give 1. But when you have 1 or 1 and 1 and 0 and 0, then it will give you 0. So now we have over here 1 and 1, right? So this will give us 0 when we have the two like digits, right? So when we have two like bits, right, then it will give you 0. and you have, when you have two unlike bits like 1 and 0 and 0 and 1, then it will give you 1. Then you have 0 and 1, so we have unlike bits over here, so we'll get 1. And 1 and 0, these are also unlike bits, so we'll get 1. So the result we get from XOR, right, that is represented by the caret symbol, will be 1 0 1 1. Next we have left shift, and this will just shift your bits to the left. So over here this will just shift this over here, so it will if we are left shifting 1101, right, so those, what this will do, this will shift it to the left and add 0 at the starting place. Right shift, what this will do, this will shift this to the right, so it will shift this to the right, right, and add 0 on the starting bit as the starting bit, right. So over here when you had 1101, when you were shifting it to the left, the whole thing shifted to the left, and in the end 0 was added, right. But when shifting to the right, right, this is shifted, this is removed, and the last bit is removed, and 0 is added as the first bit, right. So this is right shift and left shift, right, and we're all gonna see all of these in very much detail in the bitwise chapters, bitwise operators chapter only. Then we have ones complement, that changes binary digits 1 to 0 and 0 to 1, right. So what this will do, this will basically change binary digits 1 to 0 and 0 to 1. So yeah, if you have this bitwise number and you use the ones complement on this, right, then what this will do, it will change 0 to 1, so you'll get 1 over here, and 1 to 0, so 0 0, and then 0 to 1 1. So 0 1 1 0 is basically converted to 1 0 0 1, right. So it changes 0 to 1 and 1 to 0. So these were all of the binary operators in brief, right, that we're going to see in detail in the next class, right. Now we can move on to the next assignment operators, right. So I hope that part was clear, the bitwise operators.
Yeah, they were here.
All right, great. So next we have assignment operators. So these operators are used to assign value to a variable. So these are used to assign a value to a variable. So the left side operand of the assignment operator is a variable, and the right side operand of the assignment operator is a value, right. So you have a variable on the left side of an assignment operator, and you have a value on the right hand side of the assignment operator, right. To change, basically to assign or change the value of your variables, you will use the assignment operator. So value on the right side must be the same data type as the variable on the left side. So if you have specified that the variable on the left side is of integer type, then you have to set it to an integer value only. You can't say that the variable on the left side is of string type and you're setting it to integer, right. If you have created a variable of integer type, then its value should also be an integer type, right. So its value should and can also be an integer type only, right. So over here, first operator, we have the assignment operator, that is the equals to operator. So this basically assigns the value to the right of to the variable on the left. So if you have int a equals to 2, it will basically set the value of a variable to 2, right. Next you have add and assignment operators. This is called add and assignment operator, that is plus equals to. So this will first add the current value of the variable on the left to the value on the right, and then assigns the results to the variable on the left. So basically over here what you have, if you have 2 over here, a equals to 2, b equals to 4, and you say a plus equals to b, so it will, whatever pre-existing value of a you had, it will add to that value. So a's value is already 2, so we'll add b to it, right. So this will add 4 to it, so a's value will now, in the new value of a, will now be 6. So now with assignment operators we are going to continue with in the next class, as the meeting is about to end.
Thank you.
Thank you.